All right. Okay. Okay. Now,
Okay.
when the query comes to your library cache, all right, what happens is the very important operation called as parsing is being performed. Okay. The operation
Okay.
name is parsing. Your parsing operation involves few steps. Okay, whenever any SQL statement comes, it goes to your library shared pool, inside shared pool, there is a library cache. Inside library cache, a parsing operation will be performed, which perform four different steps. Okay,
Mhm.
first one is your syntax check. That means it will check whether all the syntax, like select from, all the keywords are being properly used or not. Okay, so for example, I okay, so now this is my yesterday's virtual machine. So if I do
Mhm.
select stuff from HR.employees where department underscore ID is equal to 10. Alright, so see, can you see this error? Okay, apart from that, I'll show you. Okay, now this error is because this where, the spelling of where is not proper. Alright,
Right.
right? So now if I do it properly, okay, can you see? We are getting the output. Okay, so this is called as your syntax check. It will check whether all the keywords which you are using in your SQL query are proper or not.
Mhm.
Okay, it you can okay, this is one type of error. Sometimes people will make mistake in writing from. Okay, so this can be even
Right.
like select star. All right, it will give me an error like from keyword not found where expected. This is because I have not used the proper spelling for from. All right, so
Okay.
whenever you are doing any types of spelling mistake in your query, it will be checked during the process of your syntax check.
Okay.
Okay, now after the syntax check is passed, that means all your spellings, all your keywords which you have used are proper. The next check which will be performed is going to be your semantic check. Okay, in this check, what your database will do is it will check whether the database objects, that means
Oh, okay.
the tables, okay, the tables which I am using are present in your database or not. That is first point. Okay,
Okay.
secondly, it will check whether the user, okay, currently I am with the user sys. If I do show user, it is sys. Okay, so it will check whether the
Yeah.
user is having the privilege, at least the select privilege, on the particular table or not.
Okay.
Okay, and third thing is whether the user will is able to make any changes, whether he is having the privileges to perform any changes on the particular table. Okay,
Okay.
so if I fire the above query, all right, can you see this? The table of view does not exist.
Right.
All right, so any such errors which you get while performing an operation on any of the table, which three operations? First one, you're trying to select something from a table. Second thing, you are trying to perform any modifications from a table. And third thing, you are trying to work on tables which are belonging to some other user. like this table employees belongs to HR. All right, so HR is the owner of that particular table.
Yeah.
Okay, so any of these three operations will require the table to be present inside your database and you having privilege to work on that particular database.
Okay.
All right.
All right.
Okay, so this is called as your semantic check. The next one is shared pool check. This I will tell you once I complete my parsing. All right, so after semantic check it will come on to your optimization. Okay, now optimization is the process where your optimizer, all right, the process which will perform this is optimizer. Okay, what will happen over here is your optimizer will check which is the best possible way to execute your query so that the resources utilized, and the resources in the sense the RAM and the IO, the memory of CPU that utilized should be less. Okay, so this is the work which is done during an optimization, and thus this is being performed by optimizer. All right, optimizer is an inbuilt process which is present in the Oracle database itself.
Mm-hmm.
Okay, now after your optimization is complete, after the Oracle decides which is the best possible way to execute your query so that the performance, so that the query which is being required, the output is given faster, execution will be done. Now for doing an execution, the command which you have fired needs to be converted to a hash value. All right, that means it should you did the machine language, like you are you aware about ASCII code?
Yeah, ASCII code, yeah.
Yeah, so that is a machine readable format, right, for every alphabet.
Right.
Similar way,
Yes.
every English which you fire on your database needs to be converted to a language being understood by the Oracle database, and that is done by a hash value algorithm. And it generates your hash value. Now remember, every individual query which is being fired inside your database will have a particular hash value. It is just a unique ID provided to your every single SQL statement. Okay.
Okay.
Okay, so now your query comes to your shared pool, your query comes to your library cache. Inside library cache, the parsing operation will be performed. Okay, inside parsing, what it will do, it will first check the syntax, semantic, it will generate the hash plan, or it will convert those commands into Oracle database readable format. Then optimizer will decide the best possible way to execute the query, and then the query will be executed and this output is being reflected on your screen. Okay.
Okay.
Okay, now when you are doing, okay, now it happens that you don't fire the every time you don't fire a unique query, right? Sometimes it may
Right.
happen that you generally in your banking process, when they perform update select, basically those are everyday's command, day in day out command, right? So if your Oracle database keeps on generating a execution plan for every single command, the performance will be slow, right? Right,
Yeah.
it will need time to generate a proper plan, or it will need time to generate a way in which it can execute that every query properly. So to avoid that, the parsing is being differentiated into two different ways. Okay.
Mm-hmm.
Okay, now suppose you have fired a query. All right, let's say I have fired this query. Okay, select star from HR to employees where department ID is equal to 10. All right, so this query has I fired, it will perform syntax check, it will do semantic analysis, then if this query has been fired for the first time, okay, if the
Uh-huh.
query has been fired in your database for the first time, it will go through all the process. Okay, it will go through hash value generation, it will go through optimization, and then the query will be executed. All right. But if the
Okay.
query has been already executed in your database, that means the hash values are already present for that particular query, right?
Right.
So if the hash value is present, what your Oracle database will do is it will match that hash value with previously executed hash value, and it will skip the optimization part,
An optimizer. Right.
right? So directly the output will be retrieved on your screen. This will increase the response time required to fetch the output for a particular query,
Right.
right? So this is what is being performed in your library cache. The most important operation performed in your library cache is parsing. Hello. Hello.
Hello.
Yeah. So now
Yeah.
I will explain you in brief how your parsing is being done. Okay. A user sitting on his client machine fires an update. Okay.
Mm-hmm.
This update through user process will be forwarded to server process. Okay. In your shared pool. Okay. This is your same shared pool which is present over here. All right. So in your shared pool, you have library cache, which will where all the recently executed hash values will be present. Okay, will be in the form of numeric digits.
Okay.
Okay, now let's consider the case of your this query which we have executed. All right, this we have since we have executed it earlier. Okay, the hash value
Yeah.
for this particular query is already stored in your PGA. Okay, I'll just brief you.
Okay.
Can you see this program global area, this PGA over here? This is
Yeah.
your
Yeah.
program global area. Okay, it will store all your hash values and cursor information. Okay, basically,
Mm-hmm.
whenever you are performing any operation on a particular database, the queries will come to your shared pool, and the whole execution plan will be stored in the form of cursors. Okay, in the form of implemented cursors in your PGA. Okay, so during the parsing operation, what your Oracle does is first it will check whether the hash value, okay, let's say this 608, okay, the end value 608, whether it is already present in my PGA or not. Okay, can you see here this shared
Right.
sequential area? Okay, right, there's a new XML hash value which is being generated, that is 608. It will match whether it is already present in 608 or not in your PGA or not. That means already a execution plan is present with database for this particular SQL query. All right.
Right.
So instead of doing optimization, it will simply use that execution plan and it will throw you the output.
Yeah. Got it.
Yeah. Clear with the parsing operation, how the parsing is been done.
Yeah. That's very clear.
Yeah. Okay. Thanks. So now moving ahead from library cache, you have data dictionary cache. Okay. Data dictionary is just dictionary of all the objects present inside your database. Okay. When I talk about objects, I mean tables, indexes, synonyms, sequences which are present within your database. Every information will be present within your data dictionary table. It is just like if you use an Oxford dictionary, you will find all the words of English present over there and their meaning, right? In
Right.
in the similar way, you have a data dictionary present in your database, in which all the objects present inside your database will be referred, and what is their use is will be referred over there. I'll show you a screenshot. All right. Can you see the table name and comments? Okay, so now if I
Yeah.
do select star from DICT or dictionary, okay, can you see there are 2600 objects which are present inside your database, and this will contain information about every single object present inside your database. Let it be a table. Can you see these tabs? This is
Yeah.
synonym for user table. Okay, similarly there will be for index, for sequences, for everything. All information will be present inside your data dictionary table. Clear with data dictionary?
Right. Yeah.
Right. Okay, now next component moving ahead is your UGA, that is called as your user global area. Okay, when you talk about user global area, okay, this user global area is only helpful at the time of taking backups. When you take a backup through of your particular database, instead of providing memory from PGA, you can provide additional memory from your UGA so that the backup operations become faster.
Okay.
Alright, so UGA is only to provide additional memory and to increase the performance of your backup and recovery operations. Alright, so this is the use of your shared pool. Moving ahead, the next component is your data buffer cache. Okay, now this data buffer cache is very important component because whenever you fire an update or whenever you fire any DML, every operation will be performed over here first, and then it will be written to your physical files. Okay, like I said yesterday, your complete database architecture is divided in two parts. Okay, this whole particular part will be on your RAM. All right, so this is called as your logical part. All right,
Okay.
your SGA and your background process. Okay, whereas all these files, all right, these files will be physically present on your local machine, all right, on your database server. Okay, so every operation before for being forwarded to your physical files, it is being operated and it is being performed on your data buffer cache.
Hmm.
Okay, so now I will explain you in brief how your data buffer cache works. All right, now let's say you fire a query. Okay, you fire an update query. I fire update employees, set salary is equal to 1000, where employee underscore ID is 500, is let's say 101. Okay, and for our records we'll assume that 101 salary is currently 500. All right,
Hmm.
so in this query what it will do is it will try update the salary of employee whose employee ID is 101 to 1000.
Right.
Okay, so now whenever any such operations are being transferred in your or are happening within your database, what again the same process will be followed. It will first come to shared pool, everything parsing operations will be performed, then it will be forwarded to your data buffer cache. Okay, so now in your data buffer cache the important parameters are there. It will use two blocks. Okay, there are four different states of your data buffer cache. Okay, the states are free, pinned, used, and dirty. Okay, when no operation is being performed on any of the blocks within your data buffer cache, it will be referred to as free. Okay. Now to perform an operation, what your Oracle server process will do is it will pick two blocks. Okay. One block from your users. Okay. This is your user data file. Can you see over here? This is
Yeah.
basically the data of a user is being stored over here. So this is your user data file and this is your undo data file. Basically, it is similar to your control Z, right? You do in your Windows, you do control Z, the previous image gets loaded on your Word file, right? Similar way,
Right.
in your undo, all the previous images are being stored. So I will brief you about this on your when we come to data files. Okay, so what happens is it will pick two blocks from one from your user and another one from your undo, and it will mark or it will pin two blocks from your data buffer cache. Okay. Okay,
Okay.
so now the state when your server process is marking two blocks for performing an operation, the state of data buffer cache block will change to pinned. Okay. Next is your server process, your database writer will load the value, that is the currently 101 salary is 500. So it will first load onto your data buffer cache block, which is being marked for the operation. Okay. And then the state of your block will be changed to used. Clear?
Okay.
Clear? And next, before performing the operation, what your Oracle database will do is every time, the data should be secure. Suppose you perform any operation which is wrong or any corrupted information is being entered inside your database, you should be able to roll back, right? So for that, what Oracle
Mhm.
does is before performing any modification on the current data, it stores the image of data in another block which you have pinned for undo. Okay, so
Okay.
before
Okay.
changing the value of 500 to 1000, it will first mark this 500, or it will first save that 500 image to another block, and then it will overwrite the 500 with 1000. Clear?
Okay.
after this
Yeah.
After this, since this is a DML operation and to make changes permanent, you need to fire commit, right? So as soon as you fire a commit, what your Oracle database will do is the database writer. Okay, can you see this server process? This one, right? Background process, database
Yeah.
writer.
DB right. Right.
Yeah, DB writer. This DB writer or database writer will write the data from your logical files to physical. That means it will write the 1000 present in your data buffer cache to your actual physical file, so that the data 1000 will be reflected to all the users working on that particular database.
Okay.
Okay, and the 500 will be written to undo.
Oh, okay.
Okay, so in that case, if suppose a user, okay, now in this case there are two things. All right, the first thing is if you fire the commit, okay, your rollback will not work. Okay, rollback works only till last commit. Okay,
Okay.
remember this point, the rollback will work only till last commit. So once you have fired a commit, you cannot change this 500 back to 1000, sorry, the 1000 back to 500. Whereas
Mhm.
if you have not fired a commit and you have just done the transaction, then you can change this 1000 to 500 back, because you still have not committed your transaction. Okay, so I'll show you a basic demo for this. All right. Okay, I'll use this user. Alright. What we'll do is we'll create a fresh user, or I'll reset the password for this user. Alright. Now whenever you are connected to any user within your database, okay, if you want to check what all different objects which are being owned by that particular user, you can fire the command select star from tab. Alright. This tab I have shown you in your data dictionary, right? This is,
Yeah, stable.
yeah, this one, synonym for user tables, right? So it will give
Yeah.
you all the information of all the table objects, like suppose department, then it is a table which is being owned by the particular user gather. Clear? So now I'll
Yeah.
make some changes. Let's say I have select star from Word. Alright, so here I have few data. Okay, so I will change the salary of 119 to 3000. Okay, so update word set salary is equal to 3000, where employee ID is equal to 119. Alright, so now select star from Word. Okay, now for me it is showing 119 salary as 3000 because I am the owner who is performing this change, right?
Yeah.
Right, but if I use this thing from some other user, all right, let's say I create a user. All right, I provide him basic privileges, and okay, so now if I connect, all right, now I'm connected to Rahul. Now,
Okay.
okay, so now if I want to do select star from word, it will not allow me because I don't have privileges to read that particular table. Okay,
Mhm.
so I will do grant select on my table to Rahul. Hit. So now I again perform the same operation. Alright. Okay. So now I want to roll back. Okay. So now till now I have not performed any commit. Okay.
Right.
Alright. So if I directly want to roll back the change, or I want this 2500 value which was earlier salary for 119 to be reflected back, I will simply fire
But
back. Okay, it will show me rollback completed and then select star from Word. Why is it showing 300? 3000.
I guess gonna be automatically committed, or
No, this is a DML. This should not get automatically committed. Hold on. I'll create a thing here. Hold on. Set into values into 0. Wow. And 4000. Okay, I do a commit. Let's start from right. So we have Rahul. Now I'll do update. Now set salary is equal to 5000. Here underscore ID is equal to 220. Let's start from Word. Okay, now I do a rollback. Let's start from Word. Alright, yeah. So
yeah,
it was 5000. I have to change it back to 5000. Then I forward a rollback. It came back to 4000. Okay. Now, if suppose I fire this schedule,
right,
okay, I fire a commit, and then if I try to roll back, the command will execute, but the changes will not be performed. Can you see?
yeah,
It is not rollback. So remember, whenever you're firing a rollback, whenever you're dealing with rollback, the rollback will take you back only till last fired commit. Okay. So if you
yeah,
have,
before the commit,
yeah, before commit, and if you have fired a commit,
yeah,
then the rollback will not work. So after
yeah,
commit is being fired, the changes which are being present in your logical files are being written to your physical files. All right. And this writing of data from your RAM to your physical files is being done by your database writer or DB writer. Clear?
okay,
Here with the operation of your data
yeah,
buffer cache.
okay,
Okay. So now the next
yeah,
component is your LRU, that is least recently used. Can you see this block? Okay.
yeah,
This block least recently used is only for data buffer cache. Okay. And the address of free blocks will go to your LRU. That means the blocks which are being not being used till now. Okay. As I said over here, there are four different states of your data buffer cache blocks. That is your free, pinned, use, and dirty, right? So the address of free blocks will be present in your LRU, okay?
mm-hmm.
And it will be in the fashion of first in, first out, okay? That means whoever is coming in top will come till bottom if it is not being recalled, and then it will go out,
Yeah,
okay? Then comes on to your checkpoint queue. That is also again for data buffer cache. Whenever you are firing commit, okay, whenever, as like I have fired commit after performing this transaction, now the state of these two blocks, okay, the state of this and this block will change to dirty. Okay, can you see the last one? Yeah. So the
yeah,
state of block after firing a commit changes to dirty, and address of these dirty blocks. Okay. Address of these dirty blocks will be written in your checkpoint queue. Okay. So this again
okay,
also it's like first in first out. Whenever a space crunch occurs, okay, because every memory components has a predefined size. Okay, so if ever a space crunch occur, whoever has come first in the row will be moved out. Okay, for the new addresses, for the new block addresses to be stored.
Yeah.
Clear? Now
Yes.
next important component is your redo log buffer. Okay, now this is very important component in as like you want to perform whether recovery, restoration, whatever. This data of your redo log buffer and your redo log files. Can you see this section?
Yeah.
Okay, the data of your redo log buffer and redo log files are very important and play a vital role when you want to perform any restore and recovery operation. Okay, basically any transaction, okay, any transaction, even when you have fired an update, the entry of those particular transaction will be written in your redo log buffer. Okay,
Mhm.
so the redo log entries or redo log buffer will contain entries of all the transactions which are being fired or which are being happening to your particular database. Okay, now what are the contents of your redo log buffer? Okay, or what are the entries which are present in your redo log are: first one is your SCN, that is system change number. That means whenever you fire any transaction, a SCN will be generated, a unique ID will be generated to your database which will identify that a change has occurred. Okay, then transaction ID, which is the ID or which is the unique number provided to every transaction performing within your particular database. Okay, and the third one is your timestamp of that, the time at which the changes has occurred. Okay, so all these entries will be performed or will be present in your redo log buffer. All right, now what
Right.
happens is these redo log buffer entries, as I said, are very important from your restore and recovery point of view. So these entries need to be written to your physical files. Okay, your redo log
Yeah.
buffer entries are present in redo log files and it is written from instant from your SGA to your physical file with the help of log writer. Okay,
Okay.
you see this log writer? Yeah, so
Yeah.
the sequence is you have redo log buffer, data is present inside your redo log buffer. Now there are few moments I will tell you the events at which it write when we will be discussing redo log writer. So your redo log buffer, from redo log buffer, log writer will write data to your redo log files. Okay, all right. Now next comes to your Java pool. Okay, clear till here? Any doubt till now?
Yeah, I'm good.
Yeah, okay. So now next component is your Java pool. The basic use of having a separate Java pool is because the first use is 80% of your Oracle code is written in your Java. Okay, and
Okay.
all the Java related applications, whatever most of the applications base is your Java. So to perform or to perform them efficiently, to perform your Java related executions properly, you have a separate Java pool which supports the codes and algorithms for all your Java related operations. Okay, the next
Okay.
important parameter is your large pool. Okay, now this large pool is configured just to reduce the burden of your shared pool. Okay, that means this, let's say you have 10 MB of space allocated to shared pool. Okay, and your large pool has, let's say 15 MB of space. Okay, now during your parsing operation your shared pool is consuming, let's say, 9 MB of complete space. All right, So there will be a space crunch which will be occurring at your shared pool, right? So the additional space it can buy out or it can borrow from your large pool.
Okay.
Okay, the basic use of large pool is only to share the burden of memory or load on your shared pool. That's it.
Okay.
Okay. Next component is your flashback buffer. Okay, this flashback is important when you are performing flashback of a particular table, flashback of a particular database, or a particular query. Okay, so I will discuss with you flashback in detail when we'll be reading a separate topic known as flashback. There are 9 different steps, 9 different ways in which you can perform a flashback, and at that particular point to perform a flashback, this flashback buffer is being used.
Okay.
Okay, next important component is your stream pool. Okay, now basic use of stream pool is to perform. It is being used in the case at the time of replication. Okay, suppose I have a standby database. Are you aware about what is standby database?
Standby database. What is that?
Okay, now okay, I'll explain you just in short. See, what happens is you have a production database which is up and running all the time, right? But
Right.
suppose due to any natural disaster or due to any power outage or any calamity, suppose your production database goes down. That means it will cause your business to go down, right?
Right.
So to avoid that, what happens is in every industry and in every organization, every production database will have clone of their database in the form of standby database. That means we have our this database, okay, the current database open in read write mode, right? Okay, can you see the open underscore mode is read write? That means the
Yeah.
user can perform any operation on this particular database. Okay, but when you are talking about standby database, that database will be open only in mount mode. That means a user cannot perform that any operation on that particular database until and unless it is being opened in read write mode. Okay,
Oh,
and
okay.
the basic idea of having a standby database is you will have, I'll show you. Okay, so you will have a production database, okay, and another replica of that particular database. This database will be in your read write mode, and this particular database will be only open in your mount mode. All right, now there is a concept of archives which we are going to discuss now. Okay, what will happen is from your production to your standby database, only this particular archives will be shipped. Okay,
Oh,
and
okay.
these archives contain information of every action or every information present within your particular database. So every transactions are being recorded in your archives. Okay, basically every
Yeah.
data. So
Okay.
these archives are being shipped and applied on your standby database. So your standby database is as good as your production database. Only thing is it is open in mount mode. So whenever you are facing any natural disaster, any calamity or any power outage or any outage of a production database, you can redirect all the connections coming to production to your standby database and people will not be affected and the business will not be affected.
Okay.
Okay, so to perform all this or to for this particular operation, we have Steam Pool.
Okay.
This is just to transfer your archives from your production to standby database. Alright. The next important thing is your recycle tool. That means it is similar to the recycle bin which we have in your Windows. Okay, now I'll show you reset program. Now see, this is the recycle bin, another table which is present inside your particular database. That means, see, what happens is when all the implicit cursors are being formed in your library cache, in your shared SQL area, right? This one, right? Now, this also has a particular size or particular memory allocated to it. Let's say a 10 MB of memory is being allocated to shared pool, and all the 10 MB is being used by this shared your library cache. So what you can do is, instead of deleting or instead of removing the entries from your shared pool, you can keep those cursors in your keep pool and recycle pool. Alright, so you can retain the cursor and you can retain the previous information for longer amount of time. Okay, so
Okay.
you don't have to perform the hard parse again and again. The difference between hard parse and soft parse is, in your hard parse, you have to perform whole syntax check, semantic check, hash value generation, optimization again and again. Whereas in your
Yeah.
soft parse, or you only have to do syntax check, semantic check, when the hash value is being caught. That means if the hash value is similar to some other hash value which has been fired earlier, you don't have to perform optimization. You just have to execute the query,
All right.
right? So this
All
is the
right.
use of all the memory components which are being present in your SGA.
Yeah. Okay. Good.
Okay, good. Any doubt till now?
So far, okay.
All right. So moving on to your background processes. Okay. Now apart from shared, now your complete instance. Okay. When we talk about instance, the complete instance is comprising of your SGA and background process.
Yeah.
Okay. When I was discussing you yesterday, I told you whatever is there in our mind. Okay. We use our hands to write it down on our notepad or on our computer, right? So in similar way, your database makes use of your background processes to write things present inside its memory to physical files. Clear? What is the use of background process?
Right.
Okay, so now we'll discuss one by one. Now first coming on to archiver. Okay, this is ARCH, which means archiver process. Okay, now the use of archiver is how. Okay, now let's say you have redo log buffer, you have log writer, which writes entries present in redo log buffer to redo log files, right? Now,
Yeah.
now remember, whenever you're talking about redo log file, for Oracle best practice, Oracle always recommends you to have at least one redo log group. Okay, these two redo log, this two is called as one group, and this two is called as another group. Okay,
Okay.
so Oracle always recommends you to have at least one redo log group, and each redo log group should have at least two members. Okay,
Okay.
now this member means these both the member will contain same data. Okay, the data which is being written over here is the same data which will be written over here. All right.
Okay.
So in case if one of the redo log file is lost, you can have another redo log file to operate with. All right.
Okay.
Now, what happens is, if suppose your redo log buffer, okay, entries from your redo log buffer is being written to your redo log files, your wire log writer, and one of the group is filled. Let's say the name of this group is 1 and name of this group is 2. Okay. Now one group is filled, then Oracle needs to switch from this group 1 to group 2, right? This process is called as log switch.
Yeah.
Okay, the switching from one redo log group to another redo log group is called as log switch. Then Oracle will write the entries in your redo log group 2 and in both the members. Now suppose this redo log 2 group also gets filled up, okay, and Oracle have to switch back to redo log 1. Now what we have discussed is that this information present in redo log file is required for restore and recovery, right? So as a customer, I can demand you that I want data which was 1 year back, which was 1 month back, or 1 day back, right? So I need to retain this information. All right. Now to retain this information, your database should be running in archive log mode. Okay. There are two different modes in which a database run. First one is your archive log mode, and second one is no archive log mode. Okay. Now difference between these two is, if suppose my database is running in no archive log mode, right? And whenever the log switch happens and it has to write back to the first group, it will simply overwrite this data.
Mm-hmm.
All right. That means the information stored earlier in this particular group is already lost. Okay. And this log writer writes data from redo log buffer to redo log file in every 3 seconds. Okay. In every 3 seconds, after every commit you fire, and 1 MB of changes have been made. Okay, so in any of these three situations, your log writer will write data from redo log buffer to redo log files. And if it overwrites the data present in redo log file, that means the previous data cannot be restored, right? You can only restore the data till whatever amount of data is present in your redo log files, right?
Yeah.
So to avoid this, what we do is we keep our database in redo in archive log mode. So in this mode, what happens is before overwriting the data present in your redo log file, Oracle will first archive the data present in your redo log file, and then it will overwrite the existing data. Clear? So now this data which is
Right.
being present in your archive can be kept on your local hard disk, and if local hard disk is getting filled, you can keep it on another external storage or a shared array of storage or whatever, right? So at least depending upon the requirement of a client, you can store data for 1 year, for 2 year, for 10 years, how much amount of time you want to store, providing the space is available, right?
Okay.
Okay, good enough. Understood what is your archive log mode, how your data is written from redo log buffer to redo log file.
Yes.
Yes, so now I'll show
Yes.
you by default mode. Okay, now if suppose you are working on a database, okay, and you want to check what is the mode in which your database is currently running, so you can simply fire the command archive log list. Alright, so this shows my database is running in archive log mode. That means my for every action or for every information which is being present in my redo log file, that means over here everything before being overwritten will be first archived to somewhere. It is similar to, you use mail, right? You use Gmail, you use Outlook, so you keep a copy of
Yeah.
those mail stored somewhere securely, right? So that
Yes.
the data is being first, so whenever you require previous mail, you can check the mail from your archived data. So in the same way, you have in your database, you can keep your database in archive log mode. Whenever you create database using graphically, okay, by default it is being made in no archive log mode.
Oh.
Okay,
Okay.
so I'll show it over here. This is a graphical database. So archive log mode. Alright, so it shows me no archive mode. That means my database is currently in no archive log mode, and the information in my redo log file will be overwritten before copying it to some other location. Right? So now I will have to
Yeah.
convert it from no archive log mode to archive log. Right? So to do that, first I have to shut down my database.
Okay.
Shut down database. Alright. Once your shutdown is successful, you have to start database in mount mode. So I'll fire.
Oh,
Alright. Okay. Can you see this size? Alright. This is data buffer cache size, redo buffer size. So this was the
yeah.
size I was talking about for these individual components. Okay.
Yeah. Okay.
Okay. Now my database is in mount mode. I can check open underscore mode from v dollar database. So it is mounted. Now I will fire the command alter database archive log. Alright, now I can check archive log list. So it shows my database is in archive mode. Right,
Okay.
now my database is mounted. So I'll fire alter database open. Alright, my database is altered. Now I can check which mode it is being opened in. So it will show me read write. Yeah.
Yeah.
So easy step to convert it into archive log mode. You have to just shut it down. You have to open it in mount mode, and you have to
Mhm.
fire the command alter database archive log. It will be converted.
Okay.
All right. So moving ahead. So this is the way. Now you want to check the location where your archives are present, right? So now
Mhm.
when you see here, it shows you archive destination. All right.
Okay.
So I'll choose show parameter db recovery file dest. So this is your fast recovery area or flash recovery area. Alright. Now this fast recovery area, okay, this is a area or this is being introduced from 11G. Okay,
Yeah. Okay.
okay, I will show you. So remember yesterday we were talking about Oracle Home and Oracle Base.
Yeah.
Yeah. So this is my Oracle Base where
Base. Yeah.
all everything related to like my database home, okay, this product, then my diagnostic locations, my data files, my fast recovery area, everything will be present, right? Now
Okay.
what is this fast recovery area actually is? Okay, this is a area where all your recovery related files will be present. Okay, that means when I talk about recovery related file, it will consist of your online redo log file, it will complete consist of your backups, and it will consist of your archive logs. Okay,
Okay.
so whenever you're, this is called as Oracle flexible architecture. Okay, I'll list it out over here. Oracle flexible architecture, also called as OFA. All right, it basically means that for best practice, what Oracle has done is Oracle has provided few directories to be, you know, created when you are creating a particular database. Let's say Oracle home, Oracle base, then path, even your fast recovery area. The basic use of your fast recovery area is whenever you are performing any restore and recovery operation, instead of searching out files throughout your local hard disk or throughout your OS, you can directly come to your fast recovery area and you will find all the required files. Yeah, because to perform
Okay.
any recovery operation, you only need these files, online redo log files and your archive logs. If this is present, you can perform any type of recovery requested by your client.
Okay.
Okay, good enough?
Yeah, it's good.
Yeah. So moving ahead, clear with what is the use of archiver and redo log and log writer?
What is that?
Okay, any doubt in archiver or log writer?
No. Yeah, I'm good.
Okay. Next, moving ahead, next background process is your MMON. Alright, this is also called as manager monitor.
Oh, okay.
Okay,
Okay, well,
manager monitor. Its only use is to generate snapshots. Okay, its use is to generate snapshots and store it in AWR. What is snapshot and what is AWR is, see, whenever you are using performance, okay, whenever you are facing performance related issues, okay, what Oracle does is at every instance, okay, I'll show you. At every so interval, it will create few snapshots. Okay, now if I do at the, okay, so this is my, what is the basic use of your AWR report is, you can check every information related to diagnosis or related to any event or related to any problem occurring within your particular database. Okay, so I'll just show you a view how your AWR look like. So let's say I want it in HTML format. Okay, it is asking for me number of days, so I'll say 1. Now can you see this snap ID?
yeah.
Yeah, so this is 14 November 16, this was 6:33 p.m. and then next one was 7:30, right? So after every
Yeah.
interval, by this is by default interval, that after every 1 hour of interval your Oracle will create a snapshot, and what it contains in your basically snapshot is it at that particular point in time. Okay, basically between these two time or between 1 hour, what was your database performance, how your database was performing, what were different queries which were fired, what were the queries which were using high amount of CPU, and using those informations, you can troubleshoot if a query, if a user requests that my database is running slow, my queries are taking time to, retrieve output. So using these tool or using these reports, you can fetch what was the problem, why did this problem occur, or why was the slowness occurred in your particular database. Okay. So
Hmm.
I'll enter the snap ID. We enter begin snap, that is 75. So this is 6:30, and end snap, that is 76. Okay, so instance was shut down in between. Okay, so I will check if I have any other AWR. Okay, can you see? This is how your AWR looks like. Okay, it will
Okay.
tell you what all instances you have. It will tell you what are your different how your time at what particular time which how your database was responding, what was the amount of CPU being used, or what was the SQL execution being happening at that particular point in time. Apart from that, it can even give you SQL IDs. Okay, let's say DB time, CPU time, how much amount of time redo was being used. All right. Okay, so these are different parameters to which you get SQL. All right. Alright, I'll create a snapshot so that we can work on this properly.
Okay. Mm,
Execute dbms underscore workload underscore repository. Right, create snapshot. Snapshot. Okay, and I'll create one more snapshot. Alright, done. Now again, number of days one. Alright, so these are the two snapshots which I've created just now. Alright, so
yeah.
77 and 78. Report name, okay. We'll use it in temp. Alright, now I will go to my temp. Okay, alright. Okay, so this is what AWS report looks like. That means it will give you DB name, it will give you database ID, when was the database last startup, what is the release of your database, whether your database is a cluster or not, what is the host name, every information, okay, every information, okay, the
Okay.
snap IDs which we have considered, okay, apart from that, what was the read IO, how much IO was being utilized, okay, then how much, I'll show you this IO profile, okay, how much IO was being used, okay, apart from that, how much memory, how much SGA, how much PGA. So SGA is 424, that means it is very less, okay, and 1.6 is, that means 1.5 GB memory has been allocated to your virtual machine. So out of that, only
Mm-hmm.
424 MB is being used by your SGA, and 142 is being used by your PGA, okay. Apart from that, it will list you out different SQL queries, okay. Okay, can you see here? SQL ordered by elapsed time. That
Yeah.
means SQL ID is taking large amount of time. Okay, so
Oh, okay.
this is just an example. Okay, actual one differs a lot. There, the time utilized will be very high because it's a problem, the problematic query, and that's the reason you are looking out in your AWR. So basically, this is being tool. So these snapshots are being generated with the help of your background process called as M1.
Okay.
Okay, clear with what is M1?
Yes.
All right. Okay. Coming on to your next background process, that is called as your PMON. Okay, that is your process monitor. Okay,
Yeah.
the process monitor, it is responsible only when, let's say, you are working on your database and suddenly a power outage happens, right?
Mm-hmm.
So whenever a power outage happens, your database will shut down abnormally. All right, so all the logs and latches which is being held in your database level will be released with the help of your PMON.
Okay.
All right. The logs and latches I means whenever, let's say, I'm firing any update, right? So to fire an update, I have to lock that particular row, right? So during, like, let's say I'm firing an update and suddenly my, power outage happens, so my database gets crashed down. So next time when I start up my database, all those latches and resources which is being occupied, preoccupied, will be released with the help of your PMON. Okay, now this one here is your database writer, which I have already discussed, that it is being used to write data from your logical, that is from your RAM to your physical files.
Okay.
All right. The next important background process is your RWR. Okay, can you see this one? That is your recovery writer.
Okay.
This comes into play whenever you are using flashback. All right. So flashback is
Okay.
altogether a different topic. I'll discuss with the RWR and this flashback buffer when we'll be reading your flashback. Okay. Next comes your M checkpointer. Okay. CKPT, that stands for checkpointer. Okay, the basic use of checkpointing is, see, when now just understand it properly. Let's say you have performed an update query in your data buffer cache, right? The information of that particular transaction is being written in your redo log buffer. Okay, so whenever you fire a
Mm-hmm.
commit, before your database writer writes data from data buffer cache to physical files, your redo log buffer will write data, your log writer will write data from redo log buffer to redo log files. Okay,
Yeah.
because your redo log file contains committed and uncommitted data. Okay, basically information of your committed and uncommitted data. Okay, there is information in
Okay.
the sense, uncommitted data address it will get from undo. Yes, because we are pinning a block from undo, if you recall this image.
Yeah.
So uncommitted data address will be get from your undo, whereas committed data address can be fetched from your directly from your data file, right? So this redo log file will consist of your uncommitted plus committed data, and that's the reason it is very important at the point of recovery operation. Okay, so what will
Okay.
happen is, as soon as you fire commit, first log writer will write data from redo log buffer to redo log file, then it will intimate your check pointer. Okay, log writer will intimate your check pointer that data till now, okay, or data till this particular point is being present in your physical file. That means it can be restored if required. And then check pointer will intimate your, or check pointer will update, okay, check pointer will update the SCN numbers in your control file and all the data files. Okay, and
Okay.
then database writer will write data from database buffer cache to your physical files. Clear? Any doubt?
It's good.
Okay, I'll just repeat it again. Whenever you fire a commit, okay, your redo log writer will first write data from redo log buffer to redo log files, because it will contain address of your committed and uncommitted transactions, right? Then it will intimate your check pointer. Check pointer will update the header of your control file and all the data files with the current SCN number. SCN number means your system change number. So after commit, whatever is the system change number, that will be updated, and then your database buff, database writer will write data from data file to, yeah, physical files.
Okay.
Okay. Now moving ahead, after your checkpointer, the next important uh, process is your DB writer, which is used is only to write data from data buffer cache to data files. Okay. The next important
Mhm.
background process is your smon. Alright. Now smon is also called as the Superman of your Oracle database. The reason
Mhm.
behind this is, it is the only process which is responsible for performing instance recovery. Alright. Now what does this instance recovery mean? Okay. Now let's say your data, you are performing a transaction in your particular database. Okay, you are firing an update, and before you fire commit, that means before the data present in your instance is being written over to your physical file, you your machine shut down, right? So that means that
Yeah.
transaction is being not saved to your physical files, right? So next time when you
Mhm.
try to start up your database, what will happen is Oracle will check the SCN number, okay, the system change number present in your control file and your data file. If these two number matches, only then your Oracle database will allow you to open the database, or else it will throw you an error that the database is not consistent.
Mhm.
Okay. So now to avoid such criteria, what Oracle does is during the startup process, Oracle on its own automatically performs an instance recovery. Okay. In this instance recovery, what it does is, if the SCN number of your control file and data file is not same, okay, what Oracle will do is it has redo log file, right, where your all committed plus uncommitted data is being present, right? So it will
Yeah.
pick up data from your redo log file and dump it in your data files, right?
Okay.
Now the point is how much amount of data it will dump from redo log file to your data file, right? That decision is being made with the help of your last checkpoint. Remember checkpoint? I have mentioned that checkpoint means
Yeah.
till that particular point the data present in your database is safe, and you can till that point you can recover database if any failure happen, right? So after that checkpoint, till that checkpoint, all the data will be dumped to your database files. All right. Once now this process of dumping all the data is called as roll forward. Okay. This process is called as roll forward. Okay. Now once all the data is being dumped to your physical data files, now remember that data files can contain only committed data. They cannot contain the uncommitted data. Clear? Your redo log can contain
Yes.
committed plus uncommitted, whereas your data files can contain only committed data.
Okay.
So Oracle has to roll back all the uncommitted data. So after all the database has been put, it will roll back all the uncommitted data and bring back the SCN similar to the SCN present in control file. Okay.
Okay.
So after roll forward, it will have to roll back. Once the SCN number after rollback is same between your control file header and your data file header, your database will come to open stage.
Okay.
Alright. So only two important major things which are being performed in your SMON is roll forward and roll back. For roll forward, after last checkpoint, your data from redo log files will be dumped to the data file, and
Correct.
once the data is being dumped to data file, since data files can contain only committed data, the Oracle database will roll back all the uncommitted transactions. So the SCN of your control file
Okay.
header and the data file header will be same, and the database will come to read write mode.
Okay.
Clear? Any doubt?
Yes, good.
Good. So understood the architecture. This was the architecture of your database, the basic architecture.
Okay.
Okay. Any doubt? Any single doubt in this architecture?
Okay. I have to read and go over again, basically.
Yeah, sure, sure. You can go over it, and in our next session, you can ask doubt, whatever you have. Alright.
Okay.
So should I move ahead?
Sure.
Sure. So I'll close the architecture. You have the snap of this architecture, right?
No, I don't.
Alright. Can you tell
Yeah.
me your email ID? I will forward you this recording and
Okay, I'll write down chat box.
sure. Alright. I'll send this thing to your recording and
Okay.
alright. So let's move ahead with your database. Alright, so this was till here was the architecture, like how your query is being passed, how your query acts, what are different components acting behind your particular query, and how the data from your RAM, or that means from your instance, is being written to your physical files.
Okay. Yeah.
Alright, okay, now moving ahead, we will discuss topics like startup and shutdown of a database. Okay, now
Okay.
in your startup, there are four different phases. Okay, first one is no mount. Okay, next one is mount, and third last one is open. Great. So now, if you remember, we have done over here. Alright, so now my database is shut down, right? Now,
Yeah.
the first stage of starting your database, or whenever you fire a startup, what it goes is the first stage is your no mount mode. Startup no mount. Alright. When you do startup no mount, it reads or it searches for a parameter file. Okay, the file name is called p file or sp file, where your sp stands for server parameter file. Okay, now these files are being present in your Oracle home directory. Okay, inside your Oracle home there is a folder called DBS. Inside that DBS these files are being present. Okay, so I'll show you. I'll close this since this is not required. Okay, now if I do echo dollar Oracle underscore home, okay, Alright, so I'll copy this. Go. Okay, now inside that there's a directory called DBS. Alright, can you see this file, init file and sp file?
Yes.
Yes. So now this
Yeah.
init file, this p file will be with the name of init sid. Sid means whatever name of your database is. So init sid.ora, and the server parameter file will be with the name of sp file sid.ora. Okay. Now the basic
Okay.
difference between these two files is whenever you, what is basically present in this file, I'll show you. Let's say if I do cat init. Okay. All right. So it starts from here. Okay. So basically the most important, there are only two important things which are being present or which is being read from this particular file, that is your server parameter file or init file, is the memory comp or the size of all the memory component. Can you see? This is your shared pool, shared
Yeah.
underscore pool size. This is your streams pool. This is your large pool. This is your Java pool. So the size memory component of all the memory components present inside the database. That's the reason when you fire a startup, you see this type of things reflecting in your screen, right? That means Oracle is
Oh,
reading
okay.
your P file and it has read all the size of memory component, and it has created your instance. All right. So, okay, it has created this particular part after reading your.
Yeah. Okay.
All right. Next, if by default Oracle will always look for your SP file. Okay.
Okay.
Okay. So your SP file is by default. If this file is not present, then it will look for your P file. Okay. Now the basic difference between your P file and SP file is you cannot use VI or any of the editors to perform any edit in your SP file.
Okay.
Okay, you have, if you want to make some changes manually in your parameter file, like if you want to change any component, or you want to change the location of your control file. All right. So for that you need to first create a P file from your SP file, and then you need to start your database with that particular SP file or that particular P file. Clear? So when you are doing,
Yes.
when you are creating or when you're firing the command of startup no mount, that means it is reading what is the memory component, or it is creating your instance, and it will read the location of your control file.
Okay.
Okay. Now suppose I want to create SP file from this, or I want to check whether my database is up from SP file or P file. I can fire the command show parameter sp file. Alright, so it is giving me a value output U01 app Oracle product and sp file name. Alright, if this database has been started up with the use of p file, you will get a blank over here. You will not get any output.
Okay.
Okay, so now the way to create a p file is create p file is equal to, you can choose any location in it, 141116.aura from sp file created. Now I will shut down my database. Now I will move this file by default file, that is your sp file. Alright, so my file is currently not present in my this thing, neither my init file is present. Alright, can you see any file with the name aura11g, init file or sp file? It is not there, right? So I will do a startup, it should give me an error. Can you see, could not open the parameter file u01 lab dbs and all this location. Okay, now since it was not able to find sp file, it has given the name of init file, right?
Okay.
But since I have created a p file in my different temp location, I can use even this format to start up my database. Startup no mount p file is equal to, you can give this complete location. Alright, so my database is come to no mount mode.
Okay.
Okay, good enough. So you can either start your database with sp file or p file. The basic difference between your sp file and p file is you cannot make any changes in your sp file directly using a editor, whereas in your p file you can make any changes. So suppose your database is running with sp file and you want to change any of the memory component. First create a p file from your sp file, make changes and start your database with your current p file.
Okay.
Alright, now if suppose you want to create a sp file from this p file, again the command is same, create sp file from p file is equal to, give this complete location. Alright, file created. Now again come and check over here if this file is created.
Yeah.
Okay, so if you do a shutdown and you do startup no mount, it will read the memory components, it will create your sga. Okay, so now clear with the no mount mode. Okay,
Yeah.
so in your no mount mode it will read size of memory component and it will read location of control files. Alright, now once it is done with no mount mode, it will come to mount mode. Okay, inside your mount mode it will check the location of redo log file and database files, or you can say data files. Alright, from the extension point of view, your control files will be with the extension of .ctl, that is control, whereas your redo log files will be with the extension of .log, and your data files will be with the extension of .dbs. Okay, so now let's check what is there present inside your control file. Okay, so my database is in no mount mode. I will put alter database mount That means it will read my control files. Alright, now we will see what is present inside this control file. Okay, so can you see this whole part?
Yeah.
Yeah, so this is what is the valuable information present inside your control file. That means it will contain the location of all the redo log files, their size, and your data file.
Okay.
Okay, and you can have database name, reset log mode, what is the mode, archive log mode or no archive log mode. Okay, your log file locations, all I have 3 log file group. Each log file group is having one redo log file, and I have default database files. Okay, so different 6 database file, and this is the character set which I use for my database. So out of all those files, only this is what is the critical and important information present in your control file. Okay, once it gets the information about all the redo log file, data file, and since it is already read the control file, at the last stage, that is before opening your database, it will check SCN number at header of control and database files. Okay, remember the SCN number I was talking about over here. Okay,
Yeah.
so it will
Yeah.
keep the SCN number over here. If the SCN number are same, then it will allow you to open database in read write mode. Otherwise it will ask you for recovery.
Okay.
Okay, so now I will fire the command alter database open. So it has opened my database. Okay, so 3 different stages. First, startup no mount. It will read the P file, in which it will read the size of memory component and location of control file. Then we will open it into mount mode, where it will read the contents of your control file. That means it is going to read the location of your redo log file and data file. And the last stage is we are going to open the database. So it will allow us to open database in read write mode. Good.
Yep.
Yeah, so this was the startup sequence. Any doubt in this?
Good.
Alright, so similar to your startup, how you start up your database, the reverse of this is your shutdown. Alright, now before you perform a proper shutdown, okay, what your Oracle will do is all the data, okay, before, let's say you have fired a shutdown, so all the data of your redo log file will be written, redo log buffer will be written to redo log file with the help of a log writer. Alright, that means it will contain all the committed and uncommitted transactions. Then your log writer will intimate your checkpointer. Checkpointer will update the headers of your control file and data file till last checkpointing location. Okay, then your database writer will write the available data from your data buffer cache to your database files. Alright, and then your database files will be closed. Okay, when you are opening your database, that means the database files are available for users to perform any modification. Alright, when you are closing the database, that means you're restricting users from making any action. on a particular database. So first you will close the database files, then you will dismount the database. That means you are closing the location of your redo log file and data file, and then it will come back to your normal shutdown prompt. Alright. So there are four different types of shutdown which are being available. Okay. Can you see this? This one is your
Yeah.
normal shutdown, which we generally fire. Okay, that means you simply fire the shutdown command. That will be normal shutdown. In general, what we always use in industry is your shutdown immediate. Another one is shutdown transactional, and the last one is shutdown about. Okay, so now the difference between these is, suppose you fire a shutdown normal. In any of the shutdown, whichever you fire, no incoming new connections will be allowed. Okay, okay.
Okay.
The next difference is, let's say you fire a normal shutdown. It will wait until the current session ends. That means, let's say I'm logged in with SQL Plus and I fire a shutdown. Okay, I'll show you an example. We have two different sessions. If I commit, okay, and I fire a commit. Alright, now I fire shutdown. Alright, this shutdown will keep in wait state. It will keep in wait state until all the users log out themselves. Okay, it will not forcefully log out every user. See, if I do
Okay.
over here exit, immediately it will start doing the database closed,
Yeah.
discounted and all. Alright. Whereas if
Okay.
I am using shutdown immediate, it will not wait for the sessions. Similar is for transaction and abort. Okay.
Okay.
Okay. Now, next important point is, suppose you are performing any transaction. Let's say I'm using any update. Okay.
Uh-huh.
So if you're performing any transaction, and if there are some uncommitted transactions available in your database, your shutdown normal and shutdown transaction will not allow you to shut down the database till either they are committed, or the session is being killed, or the changes are being rolled back. Okay, three times.
Okay.
Either the commit is being fired, or the rollback is being fired, or the session is being killed. Okay, whereas immediate and abort will not wait for them to end. They will simply shut down the transaction database and they will roll back the transactions. Okay. And the last difference is, it forces a checkpoint to close. Remember, this has to deal with your checkpointer. Okay. Whenever, that means whenever you are shutting down a database, a checkpoint should happen. Okay, checkpoint should happen means at least the data currently present in your RAM, that is in your temporary memory, should be available somewhere in your physical files, so that if you are unable to start your database, or if you are unable to start your instance, you should be able to recover that data from your redo log files. Okay, so that if any type of recovery is required, you can perform a recovery using redo log file and archives. Clear? So if your checkpointing is
Yeah.
not done, okay, that means the redo log writer has not intimated checkpointer that a checkpoint has been made. Then if you open the database next time, all right, your database will ask you for recovery. That means it will need the last modified data to be written to database. Okay, because the SCN number of control file and data files will be different.
Yeah.
Clear? So that's the reason, if you want the checkpoint to happen, use any three of these type of shutdown. And always remember, never throughout your industrial life, you should not and you should never shut down your database with abort option. Okay? Because if you do a shutdown abort, it is 100% sure that whenever you open a database with next time, alright, if you ask if the database is not being shut down properly, it is going to ask you for recovery. Okay?
Oh, okay.
Shutdown abort is something which you should avoid. and you should not perform.
Okay.
All right. So clear with this shutdown types, different shutdown type modes of a particular database.